Okay, so I'm Christopher Allen. I've been involved in the internet cryptography from the beginning. I am the co-author of the ITF-TLS 1.0 protocol. In more recent years, I've been involved in digital decentralized identity. I was co-organizer of ID 2020, the UN Summit on Digital Identity, where I introduced the concept of self-sovereign identity. I am the co-author of the W3C Decentralized Identifiers International Standard. I am founder of the Rebooting Web of Trust workshops, where a lot of these standards were incubated and moved forward. And I am currently an invited expert to the revised DID 1.1 and verifiable credential 1.1 working groups. But for this project, my primary role is as principal architect and executive director of Blockchain Commons. And of course, you're going to hear this over and over again, but it's important. We're a community that brings together stakeholders to collaboratively build open and interoperable, secure and compassionate infrastructure. That's why we are here. This is the kinds of challenges that we want to address. And we design decentralized solutions where everyone wins. And to do that, we're a neutral not-for-profit to enable people to control their own digital destiny. So the challenge that we're facing with a lot of our work is that is this what I call the single signature paradigm. And this model has been the foundation for security since it was really, public key cryptography was invented in the late 70s, early 80s. One private key, one public key, one identifier. But this technology, this approach is 50 years old. We need to move beyond it, and I think we now can. Why do we need to move beyond it? Well, first off, um, uh, the private keys in particular are single points of compromise. They're single points of failure. There are lots of different problems such as key fragility and bit rot that need to be addressed. And increasingly, we're finding side channel attacks on hardware is a problem. And as been expressed in our previous presentations, there's some really interesting challenges with key rotation. So you can, have a new key, but then what do you do? What do you do with the old ones? What permissions do the old ones have? How do you do so sort of after the point of compromise or after the point of failure, et cetera? So we need to address these. And these problems are not theoretical. Shannon and I wrote a book called Smart Custody in '99, where we talk about 28 different adversaries of keys, loss by acts of God, computer error, crime, government mistakes, and privacy-related problems. So if you're interested in why we're trying to move beyond this, I would encourage you to read the adversaries chapter of our book. So what we want to move toward is an identity and identifiers that are based on relationships. So uh, I coined the term self-sovereign identity in 2016. And although, we have this concept of, you control your identity and self-sovereignty is, sometimes a do not tread on me. But really, self-sovereign identity is about relationships. It's about, where the lines are where you need to control your the parts of identity that keep you intact, that keep you keep you uh, um, uh, dynamic and resilient. So what we really want to do is, connect with, you to all the other parties that you have relationships with, because you don't control the network. And while doing so, we want to support human dignity. Um, Because identity is inherently decentralized. It can and should be viewed as a network of relationships, or to describe them under graph theory, they're relational edges. These edges define your connections with others, forming a membrane around your identity. Um, this concept draws from living systems theory, where membranes allow selective information exchange, making systems resilient and dynamic. Um, this also, Thomas was talking earlier about, Mark Miller. The concept of local names and pet names is involved here, because they're really defined by the relationship itself, not by a central authority. So now, how do we turn this into the real world? Well, um, relational edges really allows, is now possible in ways that it never was before because of cryptographic tools like Schnorr signatures. Using Schnorr signatures, two parties can create a joint key pair, a group pair, each contributing a secret, but the resulting key only exists in a form that we call the cryptographic fog. This means there is no single compromised key. Even better, these multisigs are no larger than a single signature. In fact, they're indistinguishable from a single signature. Um, Thus, a public key for the group can serve as an edge identifier, while the private key allows for joint decision making, resilience, and address a lot of these challenges of the single key paradigm. So let's push this concept even further. What if instead of identifying individuals, we could create identifiers for entire groups? Think of it as being the natural next step in building a secure, resilient identity system. The edge identifier is just the foundation of this, but we can use these building blocks to create something much larger, a cryptographic clique that encompasses multiple entities. So let's talk a little bit about what a clique is. So first off, I'm going to talk about closed cliques. These are cryptographic cliques. And of course, the simplest one of these is a triad. So basically, we have an edge identifier between every pair of identities, Joshua with Mary, Joshua with Bob, and Mary with Bob. These edge keys, these edge identifiers of these relationships are then bound together to create a clique key. This group key identifies the clique. And this allows for decision making of this clique. But you can also do higher order cliques. You can do groups that are larger than three. However, closing such a graph, making sure that every member has a direct relationship with every other, becomes more challenging as the group grows. So we really have to balance between the complexity and the resilience we want as we explore the closed cliques. So some different approaches to this is we can have cliques of cliques, so the cliques are recursive. In this recursive structure, the individual entities can be replaced by other cliques, creating more complex networks. This increases the potential for flexible identity management, where different subgroups can retain distinct identities while participating in a larger whole. So what are the advantages of these approaches? Well, it decentralizes identity management. Identity creation and validation becomes peer-based, reducing central authority and improving resilience against single points of failure. Decisions can be made by cliques that are secure, distributed, irreversible, and coercion resistant, which is really ideal for group security, autonomy, collaborative governance, and individual privacy. These new cryptographic tools like Musig, Taproot, and Frost really boost the protection of identity information using these kinds of structures. There are drawbacks. This is a new, more complex technology that's going to require study. But the real question is, will people be able to give up the instant gratification to make joint decisions after multiple people have agreed? I think the results are worth it, but this is likely to be one of the biggest obstacles to widespread adoption. I want to talk a little bit more about some of the other kinds of cliques. I think they're very relevant, for instance, to the question regarding rotation. Cliques don't have to be closed. Not everything, every member needs a direct edge connection to every other member. Thus, open cliques reflect a more realistic social structure. Relationships evolve, members change, some connections may not exist at all. While this reduces some of the graph analysis advantages, it does allow for more flexibility and adaptability, which I think is essential for real-world use of this new paradigm. Uh, and then I want to talk about, a very specific form. I don't like the word fuzzy, but it's the best I've got. By basically using techniques like Frost, we can create cliques that don't require participation from every member. Instead, a threshold number of members can jointly sign to make a decision. The beauty here is you don't even need to know who participated, just that a necessary quorum was reached. This is really important for privacy and ensures the system doesn't rely on every member being available. So the other aspect of this is that cliques don't have to be about people. Devices can be parts of cliques. Forming their own identities or joining existing groups. For instance, a smart home device might create a clique to manage share access controls. Devices within the clique can cooperate, verify each other, take collective actions, all without human intervention. This further expands the potential of relational identity, making it applicable beyond only human actors. And this is particularly important when we start talking about the recursive power of cliques, where we have cliques with cliques. Doing this, we can combine devices, people, and even sub-cliques into larger networks. As you can see here, we have a device clique that is supporting Mary's and Joshua's relational edge. And one of the things that this allows Bob to do is, be very resilient because, you can create no single point of failure, no single point of compromise within a Frost federation where, one of the keys is lost. The remaining parties can basically regenerate a new key or change the threshold quorum to include new services, new devices, etc. So a lot of this we kind of talked about at the cryptographic level at our last Frost meeting. So if you want to know a little bit more about what are some of the possibilities there, I refer you to our last Frost meeting. So what are the implications for identity? Almost 2 decades ago, a friend of a friend was a format used for early social networks. In that, I could say, I know Wolf, and Wolf knows me. And we can basically represent these in a credential either with W3C verified credentials or using ZIDs. So the problem with this is that we can infer that these two parties are peers, but we can't actually cryptographically prove it. So how could we basically do that instead? So if we do this kind of in a VC style edge credential, we have a ZID that has a credential that says this is a peer group. The peer group is, my ZID, Wolf's ZID, and the joint group public key that we have verified by the joint public key. Thus, we can prove they are peers by aggregating the public key that is in each of our public key bases of our ZIDs, and then compare it to this edge credentials public key base. And this is particularly just to show how elision can support this. If let's say we want to present another credential, such as this is the homepage of this group, we don't need to reveal that in fact this group is a group. And who the parties are. Instead, we just basically allied who the parties are. And if later, for some reason, we need to prove who the parties are, we can unallied that sub-envelope. So I think I hope that this helps you understand why we need to move forward beyond the single signature paradigm. It served us for a while, but I don't think it's enough. We need identity models that reflect real relationships, ones that are dynamic, resilient, and distributed. We need to support not only personal relationships, but also our interactions with the groups and organizations that support us. Um, this new technology of edge identifiers and cryptographic cliques offers exactly that. Whether or not we're talking about closed cliques, open, fuzzy, or involving devices, the future of identity is about relationships, not isolated keys. So there are many interesting challenges and opportunities to express the richness of the paradigm, and I hope you will join the conversation as we begin to explore this in the coming year. Uh, I have an article on edge identifiers on my blog at Musings of Trust Architect, which is available on my personal blog and on the Blockchain Commons blog in this QR. And thank you very much.